Okay, it's Tuesday, the 6th of December, and we're doing volumes of revolution. Have you done that before?
Yes.
Okay. We changed last week's schedule. We didn't really do anything on Friday new. Okay, so there you go. So, let us begin with stuff. Okay, kindly consider the following volume. All right, let's draw. Let's see, wake up. Come on. Come on. Okay, let's draw a little graph here. How about like this? Consider the function y equals rad x, something like this, from x equals 0 to 4. All right, so this region here. Now, we could talk about this area, right? And I think we did. We calculated areas like this last time. Okay, but what if I take this region and revolve it around the x-axis? You get a volume. Almost like a cone, except it's sort of curvy on the sides instead of straight. If this was a straight line and you revolve this around the x-axis, you would get a cone, right? All right, so it's like a bumpy cone, okay? Or almost like a bullet shape or something. Huh? I guess. It's sort of pointy cup, okay. Well, let's say we think of our Riemann rectangles like we usually do. Let's say we do a vertical strip in thickness of dx. What if we just revolve this around the x-axis? Just this little infinitesimally thin strip of area. What if we just do that around the x-axis? What do you get? You get a disk, like a coin shape, right? Whose radius varies with the height function, the function itself, right? So how would you find this volume? Well, I can't draw too good, but let's pretend. Here's your disk. Okay? So it's going around like this, right? What's the area of the face? Well, it's a circle, right? So how do you get the area of a circle? Pi r squared. If you multiply by the thickness, which is what? Dx, you get the volume of that little slice. How do you add up infinitely many slices? That's what integration is all about. Okay, so let's write that. The volume of revolution about the line y equals 0, or the x-axis if you like, is pi r squared dx. Right? From A to B, let's say. That's what we're doing. Pi r squared is the area of the face of the disk. Dx is the thickness. And this means add them all up from A to B. Infinitely many because infinitely thin. Well, what's the radius function in this case? What is this radius here? It's rad x. So what if you square it? We're squaring the radius, right? So the volume is going to be pi, the integral from 0 to 4 of x dx. Well, is that terrible? That's not tough. So we get pi, what? X squared over 2 evaluated from 0 to 4. And the first fundamental theorem of calculus says plug in 4. So you get 16 over 2 is 8. Plug in 0. Well, that's 0. Subtract 8 minus 0 is 8. Pi cubic units. Done. Okay? Is this terrible? Going up to where? That's a general setup for a disk with vertical strips, thickness dx. All right? This is our volume that we're talking about today, right? Under rad x. By the way, the line y equals 0 and the x-axis are the same thing, so these symbols mean the same. Volume around the x-axis. All right, so if your strip of revolution about the x-axis is perpendicular to the axis of rotation, and it touches the axis of rotation, you're going to do a disk. All right? Now, did you do washers? Did you do shells? Did you do arc length? Did you do surface area? Oh, you're going to have so much fun in this unit. Welcome to BC land. All new stuff. Except for disk, I guess, yeah.
When you say washers, you mean it doesn't touch the x-axis?
Right. So big disk minus little disk, you've seen that.
Yeah.
Okay, but shells, probably not. And that's right. What's shells? Perfect. Very good. Okay, so it's BC land. Here we go. All right, let's change this question a little bit. What if I change it and now I have the axis of rotation is y equals 2? Let's take a look at that. Let's see what happens. Let's go to the next page. Let's just graph this out a little bit again. Ta-da. Ta-da. No. Ta-da. Okay. So there's x, there's y, here's 0, or the origin. Here's rad x. And let's say this is the line. No, let's use a line. Let's say this is the line. Where did it go? Ugh. Okay, this is the line y equals 2. Let's say. And this is the curve y equals rad x. Okay, and now I want this region bounded by the line, the curve, and the y-axis, okay? And I want it revolved now about the line y equals 2 instead of y equals 0. Remember, y equals 0 is the x-axis. Okay, so if I revolve this around the y equals 2 line, I get something like this. Okay? So again, we have a circular face, and we have a thickness of what? Dx again. Okay, so thickness is dx. But now what's the radius of rotation? How long is it from here to here? 2 minus the y value, right? Whatever the y value is. If the y value is 1, 2 minus 1. There's the radius. If the y value is 0, 2 minus 0. That's the radius. If the y value is 2, well, 2 minus 2. That's the radius. Right? So these disks get bigger or smaller depending on the radius of rotation. Okay, so can we write that volume out? What's the volume about y equals 2? It's going to be pi r squared dx. But what's r squared? It's 2. Who's r? You just told me. 2 what? Minus rad x. But that's the radius. What do you want to do with the radius? Square it. It's not so clear cut this time. Now what are the limits of integration since I'm doing thickness since dx and the function is in x, this better be x values, from 0 I guess to what? Isn't it 4 again? It's still 4, right? When is rad x 2? It's 4. Okay, so it's still 0 to 4. I didn't change that. So all I'm really changing is the radius of rotation. Well, how are you going to deal with this integrand? It's still pi r squared dx. It's still vertical strips disks, right? But how do you do this? FOIL it out, right? All right, so what do you get? You get 4 minus 4x to 1/2 plus x. You have to FOIL that out on the side. Go for it. Okay, I didn't integrate yet. I still got to do pi times the integral of that dx from 0 to 4. Are you ready to anti-differentiate now? What are the antiderivatives? 4x minus, well, x to the 1/2 becomes x to the 3/2 times 2/3, but we had times 4, so 8/3 plus x squared over 2. Now, this is going to be evaluated by first fundamental theorem from 0 to 4. 0 is nice because what? Drops out, so we really have to evaluate 4. So let's do so. 4 times 4 is 16. 4 to the 1/2, 2 cubed, 8 times 8, 64/3, we're subtracting. And 4 squared, 16 over 2, we're going to add 8. Okay, so this is really 24 minus 64/3. Okay, I'll get it right here. 24 minus 64/3. Let's clean that up. Can you get a common denominator? Over what?
72.
3, right? So 72. So 72 minus 64 is? 8. So you get 8 pi over 3 cubic units. They didn't give you units, so you don't have to give them. If they said x is in inches, then you got cubic inches. Okay? How's that? Is that terrible? Oh, yeah. Right. That was Skipola yesterday, I guess. Okay, so any questions how we set that up? It's still pi r squared vertical strips. Okay. That. What is that? Go away. So let's try that again. What if I gave you this? Y equals rad a squared minus x squared. I want the volume of revolution between that and the x-axis. All right, so I'm going to take that function, Take the region bounded by that and the x-axis, revolve it around the x-axis. What do you get? Well, don't you recognize this? That's a circle, right? If you square both sides, don't you get this? Where A is the what? Radius. And where's the center? 0, 0, because h and k are 0 and 0. X minus 0 squared, y minus 0 squared. Okay, so we can graph this, can't we? Let's get a feel for what this looks like. Let's see if I can draw a circle. Where's my circles? Oh, yeah, I don't like that. A little bigger. Let's pretend that's a circle, okay? Well, the problem is I don't know if it's really centered, but whatever. All right, so this is A, this is A, this is negative A, this x value, right? This x value, this y value is A too, I guess. Here's x, here's y, here's the origin. Now I want to realize that this is a function and this is not. What I graphed here is not a function, right? I'm talking about the function. Which part of this am I talking about? The top half, all right? So forget the bottom half for a minute. Let's say I do vertical strips again. Do they touch the axis of rotation? Yeah. Are they perpendicular to the axis of rotation? So this is disk. That's when you do disk. Sometimes you're not going to be able to do disk. We've got to be careful about that. All right, so again, if you revolve this around the x-axis, you're going to get a disk. It's got a circular face. What's the radius of rotation? Not always A. A is up here. Is that A? The height could be here. It could be up there. The x is the thickness. I got that, okay. But what's the radius? In other words, pi r squared dx that I'm integrating. It's the function, right? That's not over here. The function is small. Over here, the function is up to A. Right over here, it's small. All right, so that's the radius. What are you going to do with the radius? Square it. So what do you get? Okay, so the volume of revolution about the x-axis is, what should I write? Pi, the integral from negative A to A of the radius squared, so that's A squared minus x squared. Technically, it's the absolute value of that, but I'm not going to worry about that right now. And the thickness of the disk is dx. So pi r squared is the face, the thickness is dx. You've got a little slice or cylinder of volume. Okay, great. That's fine, but can you make it even easier? What was nice about this one? That's 0, right? Can you get it here too? You don't have to. But it can save you a little work later if you realize that what you're doing is you're taking this semicircle and revolving it around the x-axis from negative A to A, right? But by symmetry's sake, isn't that double this quarter circle revolved around the x-axis? So why don't I just double the volume from 0 to A? Just make life easy later on, because it's nice when there's a 0 in there. You don't have to have a 0 in there. You could work with it. And a lot of times you can't get a 0 there, but why not make it easy if you can? So what's the antiderivative now? And don't say a cubed over 3. I'll smack you. Okay, 2 pi a what? Squared what? X. Good. Minus x cubed over 3. Now I don't smack you. Okay, good. Okay, from 0 to A. Remember, this is a constant. The derivative of 2x is 2, right? So the antiderivative of 2 is 2x. Don't get all crazy now and write a cubed over 3. So let's plug in stuff. Well, plug in a, and you get a squared times a is a cubed. And you plug in a over here, you get minus a cubed over 3. And now you got 2 pi times that. And again, when you plug in 0, it drops out, so we don't have to worry about it, right? Well, what's a cubed minus a third of a cubed? 1 a cubed minus 1/3 a cubed is 2/3 of a cubed times 2 pi is 4 pi a cubed over 3. Does that sound familiar? 4/3 pi r cubed? That's the volume of a sphere. All your area formulas and all your volume formulas came from integrals, believe it or not. Okay, so what is our time up there? 15? Oh, good. Okay, let's try another one. Am I going too fast for anybody? Let me know. Stop me, slow me down, ask me a question. Yeah. I did, but the thing is, what I squared was a radical. So I squared it by getting rid of the radical. Okay, so if you square this, you're squaring it twice. It's not pi r fourth, is it? No. Okay, is that good? Any other questions? Okay. All right, Dave, let us continue. What if I gave you this weird shape? Okay. Okay, based on this function, y equals, what is it, 1 over x squared. Now, I want the volume about the y-axis. I want to revolve around the y-axis now, between y equals 1 and 4. So do we really want, I don't like that drawing. Yeah, this is y equals 1 over x squared. Let me just do a little thingy here. Between y equals 1, let's say that's 1, and 4, okay? That's not to scale, but so be it. See what happens when they say a cubed over 3. All right, so am I going to do vertical strips now? I'm revolving around the y-axis. I'm not revolving around the x-axis. I could do vertical strips. We'll come back to that next week, I think. But could you do horizontal strips? Right? What if you do a horizontal strip? I can't draw today. I'm killing my graph. Oh, it's so bad. Okay. Do this then, okay? Here's my horizontal strip, okay? There it is. No. Come on, do it. Pretend it's infinitely thin. What's the thickness now? dy. And I'm revolving that around the y-axis. I still get a disk, right? Because it's perpendicular to the axis of rotation, the y-axis. It touches the axis of rotation, right? That's a disk. What's the radius of rotation? It's going to be this x value, whatever it is, right? It's going to be smaller here. It's going to be bigger here. How do I figure that? Right, solve this for x. So, okay, let's solve for x. What if you, I don't know, what do you do to get x alone? You got y equals 1 over x squared. Well, technically that's y over 1, so you can cross multiply. So x squared, y equals 1. So x squared is 1 over y. All right, but what's x? 1 over rad y. Now I'm going to take only the principal root because these values are positive, right? These y values are positive, so I don't really need the negative. Technically, yeah, plus or minus. Okay, so that's the radius of rotation. That's this x value. All right, so can you set up an integral that is the volume of rotation about the y-axis or the line x equals 0? It's still disk, so pi r squared thickness, right? So pi, who's r? 1 over rad y. So what's r squared? 1 over y, right? What's the thickness? Pi r squared is the area of the circular face times the thickness for the volume of the very thin cylinder or disk is what? dy, and that's it from 1 to 4. And now you're going to say, I don't know how to do that. Right? Well, yeah, Heian told you you're cheating if you say it. I know you want to. ln, right? You're cheating now, okay? We don't know anything about ln yet, okay? But Hal does. Hal knows everything. Okay, Hal, let's do stuff. So we'll just do this one numerically, that's all. So secant 7, no, wait, clear that. Secant 7 of 1 over y with respect to y. And yes, Hal knows that that's ln, okay? But let's say we don't know that, okay? From 1 to 4. Yeah? And I'm in the approximate, so it gave me a decimal. If I wasn't in approximate, it would give me something in terms of ln. What would it be? It would be ln4 minus ln1, which is 2ln2, or ln4 if you like. If you go to mode and change it to auto, huh? It's 20 now? Okay. Thank you. Okay, if I go back, if I go to auto mode, it'll probably give me ln's. There you go. Okay, so if that's 20, I gotta start rendering. So let's put this away for our FTP site.